The aim of systems innovation is to change systems. So, what is systems change? Systems change is about enabling transformation in the structure and interrelationships of the parts within a complex organization, so as to realize the emergence of new behavior and functionality required for that organization to operate successfully within its environment. To quote Forum for the Future, systemic change is where relationships between different aspects of the system have changed towards new outcomes and goals, and it's driven by transformational, not incremental change. Rachel Wharton and Alice Evans, in their article on the subject, define it in similar terms. Systems change is about addressing the root causes of social problems, which are often intractable and embedded in networks of cause and effect. It is an intentional process designed to fundamentally alter the components and structures that cause the system to behave in a certain way. The terms systems innovation and systems change have arisen in parallel to the idea of wicked problems, as a new language is now entering the public sphere, seeing problems as complex, interdependent, and involving high levels of uncertainty. Our old ways of thinking about problems as the product of simple cause and effect relations are subsiding in the face of a new set of challenges that governments, enterprises, and societies around the world are now facing. It is increasingly becoming recognized that problems like healthcare are not simple in their nature. We start to recognize that they involve many interrelated factors, such as our cultural and psychological attachment to poor quality foods, the economics and finance of food production and distribution, environmental issues such as air quality, issues to do with the built environment, not to mention impacts of social relations and advertising, all of which are no longer in the control of any one organization, but instead part of vast networks of actors that we call complex adaptive systems. These kinds of issues are now termed wicked problems, which are highly complex issues. They are unstructured, open-ended, they are multidimensional, systemic, and have no known solution. Examples of wicked problems include social discrimination and cultural segregation, climate change and environmental degradation, global financial instability and inequality, terrorism and cybersecurity. In all cases, the problem cannot be isolated and separated from the system. Because wicked problems are systemic in nature, they can be understood as an emergent phenomenon of how the local components interact, of how the system itself works, and not simply one part of the system that can be isolated, tackled, and solved in a traditional linear fashion. As a consequence, the only way to tackle these problems is to try and change the system, that is to say, to do system change. Systems thinking is about looking at the underlying dynamics within the system and how that creates the system's observable behavior. Systems change is about identifying and surfacing the core contradictions in the system, rather than the symptoms created by those contradictions. As an illustration of this, we can see financial institutions funding the Worldwide Fund for Nature, but they are often not interested in looking at the environmental impact of their investments. This is often the case. The underlying structure of the organization creates issues that it then spends its time and resources on patching over. What is different today is that the underlying structure of our industrial institutions is becoming so mismatched with the environment they operate in that it is ever more difficult to simply patch over them, and there is an increasing recognition for the need of systems change. These contradictions are what create the problems of today, but they are also the source of potential change in the system. Systems represent patterns of organization and self-reinforcing feedback loops that create the typical behavior of the system. For example, in a political system, we may see politicians saying one thing and then doing another. This is, however, not the product of some random accident or some maverick individual, but a product of the system's dynamics that creates a certain recurring pattern of behavior. It is part of the very way the system is organized. Initially, we may think it is a problem with the specific attributes of the individual in that position. But after seeing that if we swap out the individual and put in another, we get the same behavior, we will start to see that is the behavior of the system caused by its underlying dynamics. In such a case, altering any of the parts, for example, electing a new president, will not solve the issue. We have to understand the behavior of the system that is creating it and change the system in some way instead of just changing any of the parts. Whether analyzing difficult market conditions, water pollution within a community, extended social conflicts, or food security, the key to tackling such issues is understanding their underlying structures and complex patterns that help support them. Some well-known patterns of behaviors which frequently lead to undesirable outcomes in the systems are called archetypes. These archetypes include burden shifting or the tragedy of the commons and are studied in system dynamics, which we will look at in a later module. The complexity of systems often gives rise to suboptimal decision-making, when decisions are made by looking at a problem in isolation instead of within the context of the whole system in which it is present. One example of such consequences in the food system is the impact of food aid. Despite its aim being the elimination of hunger, food aid is integrated into policies leading to structural food deficits and increased dependency on food imports. This kind of dependency, in union with the limited resources that developing economies have to finance their imports, may well actually lead to an increase in hunger and poverty. There is an important consequence that follows from this that Russell Ackoff states clearly when he says, "The critical point for contemporary management, it is the following. When you improve each part of the system taken separately, you do not improve the performance of the system taken as a whole, and are very likely to hurt it or decrease it, and that is completely counterintuitive." With our traditional analytical reductionist ways of thinking, if we see that there is something wrong with an organization, we believe that the failure must derive from one of the parts. The obvious consequences of this thinking is that we try to trace back the problems the system has to some specific component. Often, we ascribe systems-level dysfunctionality to a specific part in the system. If there is an issue in our healthcare system, our education system, or our political system, we try to trace the problem back to the medical staff, the lack of finance, the funding of campaigns, etc. We then try to fix that problem. But because system-level functionality and features are a product of the way the parts are interrelated, we do not solve the problem. As Russell Ackoff puts it, if you look at what most total quality management programs do, they focus on identifying what is wrong, finding the course of the error, and removing it. When you get rid of what you don't want, you do not necessarily get what you do want, and you may get something a lot less. When we try to solve problems like this, we just move them around. Ackoff gives the illustration of alcohol prohibition in the U.S. In the 1920s, alcoholism was seen as a major problem. It was seen as a defect, and policymakers wanted to get rid of it, so they asked what is to blame in causing this problem. The answer was clear: alcohol consumption. So they passed the Volstead Act, an act to prohibit intoxicating beverages. This did not have the effect of getting rid of alcohol. Though it made it illegal, it was still plentiful. What it did do, though, was create organized crime, and organized crime has been a much larger problem since than alcoholism ever was. The same could be seen with drugs in the 1960s. Complex systems are often described as counterintuitive. When we take our traditional ways of thinking that apply to simpler systems and project them onto these more complex organizations, we often get counterproductive results because they do not apply. This is the first lesson to learn about complex problems. They are not a function of any part in the system. They are a product of how the system is structured, and thus we have to change our way of tackling them from parts to the whole. That means looking at and trying to map out the structure of the whole system and how that structure of feedback loops and interdependencies creates the behavior of the system. And we will be going in depth on this in future modules. The second most important thing to learn is that you cannot directly change a complex organization. You can directly affect changes within parts, but not the whole system. A critical factor that is changing today is that we are going from designing relatively simple systems, like chairs and houses, where it is small enough and simple enough that we can impose our design on it, to dealing with systems that are much greater than we are. In a simple world, you can change the system. In a complex world, no one actor gets to change the system they are a part of. However, every actor has an influence on the system's evolution. You can choose to have a greater or lesser influence on its evolution. We can control our car because it is a relatively simple system, but we cannot control the traffic because it is a complex system. Yet each one of our actions has an influence on the overall traffic pattern. No one of us can solve climate change, but each one of our actions affects it. We give up complete control and certainty, but each one of us gains influence. Complex systems change through an evolutionary process, and thus, systems change is really all about evolution. If we look at really major changes that have transformed societies, we will see that no one person or organization created that change. Take as an example the movement of Western society from a feudal system into the modern world, which certainly qualifies as a major change within a complex adaptive system. No one director chose to make that change. No one caused it to happen. It was a process of cultural, social, economic, and technological evolution. This massively parallel set of processes and small changes taking place in all these different systems eventually coalesced to take us into a new paradigm. That is the way that change happens in large, complex adaptive systems. Because complex adaptive systems consist of all these agents making decisions locally, we can't impose a design pattern on the organization and get the desired and predicted outcomes. However, what we can do is work with the system's natural potential for change, and that change happens through a process of evolution. The job of the system innovator, then, is to understand the system and its potential for change and to create the context for those variants that may be successful to grow and become more prevalent within the system, thus influencing it in a certain direction. This process of systems change can then be seen as very much analogous to the way an ecosystem adapts to its changing environment through the process of natural selection and evolution. Indeed, that is all we can actually do as systems innovators, help the organization adapt to its environment. To think that we get to make a plan and direct the organization in the direction of that pre-specified outcome is just an illusion. It is a failure to recognize the complexity of the systems that we are dealing with. These are the two most important things to learn in systems innovation. Firstly, that it is not about the parts, but the structure of the whole system. Secondly, that you cannot impose a design pattern on a complex adaptive system and get the results that you expect. Unfortunately, it typically takes us as individuals, as organizations, and as societies massive amounts of wasted time, energy, and resources to learn these basic principles of systems change. These principles, in fact, follow naturally from an appreciation for the complexity of the systems we are dealing with. If you don't have an appreciation for the complexity of the system you operate in, then you will likely create an overly simplified model to try and respond to the issues. National health systems, the global food system, corporate supply chains, political organization, national water systems, the global financial market, metropolitan areas. These things are incredibly complex, and you need to start with an appreciation for that complexity, or you will make the same mistakes we have made countless times in the past. Making that conceptual quantum leap to embrace their complexity sets you on the right path to enable systems change, but it is just the beginning.